Today we will use Python, Microsoft SQL Server, and Power BI Desktop to display system performance information in Power BI dashboard in real time, just like Windows Task Manager. This exercise will help us learn Python, SQL, and Power BI. In this exercise we will connect three major data science applications together. We will use Python to read system performance information and insert this information into Microsoft SQL Server Database. We will then use Microsoft Power BI Desktop to read that information from Microsoft SQL Server Database and display it on a dashboard in real time. We'll start this exercise by creating a Microsoft SQL Server Database. We will create a new database in Microsoft SQL Server, named System Information. In the System Information database, we will create a new table. The first column will store date and time information. The second column will store the CPU usage information. A numeric data type with 2 decimal places will be suitable for CPU usage information. In the third column, we will store the memory usage information. Then we will store CPU interrupts, which are the signals to the CPU, requesting immediate attention. This could be a large number. We will also store the CPU calls. In the next column, we will store the memory used. Next, we will store the memory free. In the next column, we will store the bytes sent over the Internet. And also, bytes received from the Internet. We will also store the disk usage information. We will save this table as performance. Now we can refresh the tables to see the performance table in the list of tables and view all of its columns. The table is currently blank, as there is no data entered into B table. In the next chapter, we will insert the data into this table, using Python. First, we will import Python system and process utilities. Then we will import the time library. And finally the ODBC library for Python. Let's create a connection using the ODBC Python library. We want to connect to the SQL Server Database. We can find out the server name from the SQL Server Management Studio. Here, we will enter the name of the database that we just created in Microsoft SQL Server. The connection is trusted, because it is a local SQL Server connection. Let's create a SQL cursor, using the connection defined above. Let's create a never-ending loop. Using the Python system utility, we will get the CPU usage information. Let's print the CPU usage to test the code. We will give a break of 1 second to our loop. There is an error in row number 10. The code is now working fine after removing the errors. Let's add other system performance data as well. Next, we will get the memory usage information from system. The memory usage function gives us multiple values. We want the percentage value for our memory usage variable. Giving the appropriate index of the percentage value will extract the percentage value only. Now we will get the information of CPU interrupts, which are the signals to the CPU for immediate attention. We will also get the CPU calls from system. Let's get the memory used statistics from the system. And the memory available as well. This will create a nice pie chart. Now, we will get some internet usage information. First, we will collect how many bytes are sent. Then we will collect the information of how many bytes are received. Let's also collect the disk usage information. Now, that all the information required has been collected from the system, let's insert this information into SQL Server Database. We will use the insert SQL command to insert the data into the performance table we created in the SQL Server Database. We will use the getDate function to enter the current date and time. Now, one by one, we will enter all of the above variables into our performance table. After the final variable, we will close the parenthesis to complete the insert statement. We will use the connection.commit function to finalize the insert command and make the SQL Server Database accessible for other applications. To test the Python code, we will run the Python application and go to the SQL Server Management Studio and display the data to ensure that the code is working fine. The growing number of entries in our performance table with accurate data is evidence that the code is working fine. Now we will stop the Python code and connect the SQL database to Power BI. To connect the Power BI desktop to the SQL Server, we will use the Get Data feature. We will select the SQL Server Database in the Get Data window. In the Server field, we will enter the SQL Server name. In the Database optional field, we will enter the name of the database. To display the data in real time, we must always select the Direct Query Connectivity mode. In the Navigator window, we will select the Performance table. The Power BI desktop is now directly connected to the SQL Server database, and all the fields are now available for creating the dashboard. Before starting with the dashboard, we will create some measures using DAX to calculate the current values of CPU usage, memory usage, and disk usage. In the CPU usage measure, we will calculate the value of CPU usage against the latest date and time value. We will use the calculate function to extract this value. We will use the sum of CPU usage as expression, and the latest date and time value as filter. The latest CPU usage value is now available. In the disk usage measure, we will calculate the value of disk usage against the latest date and time value. Finally, we will calculate the value of latest memory usage against the latest date and time value. Now that we are directly connected to the SQL Server database, we will create a dashboard to display the system performance information in real time. First of all, let's create a title for our dashboard using the text box visual. We will add a gauge visual to display the CPU usage. Add the latest CPU usage measure to the values field. Add the CPU usage field to the minimum value area as minimum, and to the maximum value area as maximum. We will change the title of the gauge visual to the CPU usage. Let's create a copy of the gauge visual to create a disk usage visual. Change the title of the visual, from CPU usage, to disk usage. We will remove all the existing fields and add the disk usage latest measure to the values area. We will add the disk usage field to the minimum value area as minimum, and to the maximum value area as maximum. We will create a copy of the gauge visual to display the memory usage information. We will change the title of the gauge visual from disk usage to memory usage. We will remove all the existing fields and add the memory usage latest measure to the values area. The memory usage field will be added to the minimum value area as minimum, and to the maximum value area as maximum. Now, we will add a line chart to display the bytes sent and received per second. We will add the bytes receive field to the y-axis and the bytes sent field to the secondary y-axis. We will add the time field to the x-axis. We will add another line chart to display the CPU interrupts and CPU calls per second. We will add the CPU calls field to the y-axis and the CPU interrupts field to the secondary y-axis. The time field will be added to the x-axis. Finally, we will add a pie chart to display the memory used and memory-free information. We will add the memory-free and the memory used fields to the values area. Our dashboard is now complete. However, we will limit the line charts to display maximum 30 latest items. We will apply the top N filter on the time field in both line charts and filter the time by latest values. Now we are ready to test our dashboard in real time. To run a fresh test, first let's delete the previous information from SQL table. As you can see, the dashboard is still showing the data, which means it is not refreshing in real time. To do that, we will turn on the page refresh feature, and set the refresh interval to 1 second. Now our dashboard is updating in real time. Let's run our Python code, and go to the Power BI dashboard, and see how our information is being displayed in real time. Our dashboard is now updating in real time, displaying the CPU, memory, and disk usage information. Thanks for watching. We hope you liked our tutorial. Don't forget to like and subscribe for more tutorials and updates.